So we are going to be writing an equilibrium expression. And what the equilibrium expression is it is the concentration of the products over the concentration of the reactants. It is a ratio, okay? It is a ratio. And if you have trouble remembering which one goes over which one, there's a couple ways to think about it. You know, PR, like public relations, P goes over R. And if you don't like that one, if you're like, I don't know what PR is, that's not going to help me, then you can think it's alphabetical order. P comes before R, so P goes over R, okay? So concentration of products over concentration of reactants. And this is a constant value. As long as you are at a constant temperature, this value never changes. We're finishing up next week. There's section 2.3. I'm going to guess it'll be like the Monday of the week of Remembrance Day, which will be like November 7th-ish, but I'm not sure about the exact day because I don't have a calendar in my head, but yeah. Yep. Finishing the unit next week. As long as you are at a constant temperature, this value never changes. So if, now the key thing here though is that these have to be equilibrium concentrations. These are not concentrations while you're shifting, okay? So these are equilibrium concentrations. So if we do something like if we were to change the concentration and the system shifted, it would shift in order to get the ratio back to the original value. Yeah? If we were to change the volume, the system shifts in order to get the ratio back to the original value. So if we stress the system, by a change in concentration or a change in pressure volume, the system will shift to go back to the original value. Changing temperature though, changing temperature will actually change the ratio, okay? I'm realizing that I need to put a lot more space onto this handout to write things on, but you know, there we are. So products over reactants, that's nice and simple. However, we need to be able to do it for specific equilibria. So it's not quite as simple. And this might look a little overwhelming at first, but the moment we've done a few examples and you've practiced it a little bit, you'll be like, oh, this is pretty easy, okay? So don't worry if this seems a little bit much. If we have a reaction where we have substance A, substance B are our reactants, substance C and D are our products, and the little a, little b, little c, and little d, those are our coefficients. Then we can write a more specific value for this constant, this KEQ, where our products, we represent it, the concentration of product C, but we raise it to the power of its coefficients. So raised to the power of little c. We take the concentration of product D and we raise it to the power of its coefficient, little d. In our reactants, we have concentration of A, raised to the power of its coefficient, little a, and B raised to the power of little b. And the symbol that we give for this thing and the name that we give for this thing, it is called the equilibrium expression or the equilibrium constant, but we often just call it KEQ. And the K is for constant. And I know that constant doesn't start with a K, but that's okay. You can think of it that way, all right? K for constant, and EQ obviously is for equilibrium. So this is our equilibrium constant. Okay, and I know I've already mentioned it, but notice how the coefficients become powers in the equilibrium expression. The equilibrium expression includes only, because it's got concentrations, yes? It only includes substances which can change in their concentration, which can vary in concentration. So, can I change the concentration of a gas? Yes, if I make the container smaller, the concentration gets higher. If I make the volume bigger, the concentration gets lower. If I inject a gas into a system, I can bring its concentration higher. Yes? So gases have a concentration. So we are going to include gases in our equilibrium expression. So gases, we're going to say yes. Please include them. Can we change the concentration of aqueous substances? So if I dissolve some salt, I couldn't dissolve more salt? Yes, I can. So aqueous ions or aqueous gases, and when I say an aqueous gas, I mean like dissolved oxygen, like the fish use to breathe. Yes? So aqueous substances, they can change in concentration. So yes, we include them. Can you change the concentration of a solid? No, so we do not include them. If you have a bigger volume of solid, you also have more moles, so the moles per liter remains the same, okay? So no to solids. Our next rule is the most important rule for liquids. Pure liquids are not included. So really, the rule for liquids is no. What's the rule for solids? No. What's the rule for gas? Yes. What's the rule for aqueous? Yes. What's the rule for liquids? No. 99.95% of the time, that is the rule for liquids. Okay? I'll get there. So you could say this is the main rule for liquids. So when I say liquids, you say no. Liquids. Liquids. Oh, that was fun. Okay. Anyway, so when I say a pure liquid, what I mean is that there is only one liquid in the equilibrium reaction. Okay? So a pure liquid means only one liquid in the equilibrium reaction. And this brings us to the exception for liquids where we do say liquids yes, but bear in mind this happens only 0.05% of the time, so most of the time liquids, no. However, if you have two liquids, they can actually dilute one another. For example, if you have wine, it is a mixture of, I'm trying to use something you might be familiar with, right? Hopefully not too familiar. You have a mixture of maybe 12% ethanol and 88% water. Okay? Beer, on the other hand, maybe it has a percentage of 5% ethanol and 95% water. Ethanol is a liquid. Pardon me? Ethanol is a liquid. Ethanol is alcohol. It's like the famous alcohol. Okay? It is CH3, CH2, OH. Okay? If you did any organic chemistry, you'll recognize the prefix F means 2 carbons. Okay? So that's ethanol. And the OH on the end, when you have it on the end of a carbon chain, that means you have an alcohol. So if you had 1 carbon, it would be CH3OH. That would be methanol. And that's wood alcohol. And if you drink that, you will go blind. Awesome, hey? Huh? You will literally go blind if you drink wood alcohol. I don't know the mechanism. I just know that it does happen. Yeah. I mean, honestly, like alcohols and things like that, because they're organic, they do weird things to like all the systems. Like alcohol itself does, if you ever want to like never drink again, go watch what alcohol actually does to your body. Read about what a great carcinogen it is. You guys know what a carcinogen is? Causes cancer. Ethanol is a carcinogen. It's probably just as bad, almost as bad for you as smoking. Yes? In terms of raising your risk of cancer, raising your risk of liver disease, raising your risk of all kinds of things. I'm not saying this to scare you, but I am saying this to scare you because I'm not saying never drink alcohol. What I'm saying is that these problems become bad if you drink regularly or a lot at one sitting. So like once a day is probably too much on a regular basis, yes. Also, having more than 1 or 2 drinks at any given sitting is probably too much in terms of your health, yes? Yeah, drinking until you pass out, you have done permanent damage to your DNA, to your liver, et cetera, Now, it might be minor damage if you do it once, right? So if you make a mistake and you're like, oh, I was with some friends and I did a dumb thing. But if you're one of those people who's like, every Saturday night I go out and I get blitzed, I can't remember what's going on, then you are doing definite damage to your body. And it means you will live less long, which is a sad, sad thing. So Drink responsibly if you do. Wait till you're 19. In fact, you should wait until you're 25 because then your brain is finished developing and that will help. But anyway, just my little public service announcement for your health there. You should also make sure that you're taking sufficient vitamin D because we live in a climate where we don't get enough vitamin D from the sunshine. All right. Now, if we're going to finish this lesson, I need to stop giving public service announcements and say, if we have two liquids in our system, doesn't matter if they're a reactant or a product, what matters is that they are in the container, because are my reactants in a different container than my products? No, so they can dilute one another. So if I have more than one liquid, I do include it in the KEQ expression, okay? All right, let's try a few examples here. First of all, what's the very first thing we have to write? KEQ equals. If you do not write that, you lose a half a mark. Okay, is it reactants over products or products over reactants? Products over reactants, PR. Okay, so we're going to go to our product. Do we include our gas? Yes. C2H6. These ones have to be what kind of brackets? Square, because it's concentration. If you write round brackets, it's wrong. Well, that would be a half a mark. Okay, square brackets. Otherwise, you're not telling me what quantity. Here, this means moles per liter. Okay. In our denominator, are we going to include our carbon? No, because it is a solid. So we're going to have our carbon and we do not include it. Now, how about our H2? Yes. So we're going to have H2. And what do we need to do with it? We need to cube it. Yes? Because we have a 3 here, we need a cube there. Okay? Let's try our next one. What's the first thing we write? KEQ equals. Now, the product is a solid. So if I don't have anything in my products that I can actually write up there, what could I use as a placeholder for that? Just the number 1, okay? So use a 1. It does, but it's not necessary in the reactants. Like you can, if you want to, put a 1 down there, but on the other hand, it'll just be exactly the same as if you don't divide by 1. So you can choose what you want to do. I usually don't because I'm lazy. Yeah. Okay, and now we're looking at our reactants, both of which are aqueous, so we will include both of them. So I have PB. Is that okay? No, what did I forget? 2 plus. You will lose marks if you do not include your charges. Probably a quarter mark if you only do it once, up to about a half a mark if you do it like more than once, okay? If you do it 3 times, I kind of max out at a half a mark for that, okay? Yep. Basically, today is all about me telling you where not to lose marks, okay? Because the actual math behind this is super simple, okay? Yeah, like it's super simple math. Okay, and then we have our BR, which is minus with a 2. I got to remember my coefficient. Now, I'm also going to show you something else that you could do wrong. Okay? It would be wrong if I wrote KEQ is equal to 1 over PB 2 plus times concentration of 2 BR minus squared. Never put the coefficient in the brackets. It always goes to the exponent. Do you care why? Exactly. Like, I'm not going to draw it out for you, but I did draw it out for the other class, so I'll just show you quickly what it looked like, and I will post it in the notes. Because, well, what's happening there is, like, let's say I drew this, okay? And I said, this is my 1 liter here. And each of these represents 1 mole of Br. So my concentration of Br would be 1, 2, 3, 4 moles per 1 liter, yes? But if I was to say, what's my concentration of 2 Br, then I would be like, oh, well, here's 2 BRs, and here's 2 BRs. So I would have 2 pairs of Br minus ions per liter. Like, what the heck am I measuring? It's just weird. Yes? So I will post this little bit in the extra notes, but you know, it's not right to say the concentration of 2 of something. That's not something we would do. Okay, back to ours. There we go. So never put the coefficient in the brackets. All righty, now we're going to do our final one here, and guess what I see in this one? This is our 0.05% of the time. Okay, so this is very unusual. Those are liquids. And in fact, even if like that middle one hadn't been a liquid, you know, if this one was like a solid or, you know, gas or something like that, these 2 would be enough to make it 2 liquids, and so I would include them. Yes? Pardon me? And if this is an L, but if this one if it was my 2 products, I would include them. It doesn't matter where the 2 are, as long as there's 2 or more. So how would you write this? You're going to write it the same as usual. KEQ equals concentration of products. So we have CH3, OCH3, times concentration of H2O divided by concentration of CH3OH squared. And that one right there at the bottom is methanol. You recognize that OH there? Okay, that's your alcohol, and because it's got 1 carbon, that's a methanol. That is an ether. When you have an oxygen in between 2 carbons, that's an ether. Have you heard of ether? They used to use it as an anesthetic back before they had real anesthetics. Yeah. Yeah, organic chemistry has all kinds of patterns, right? So the COOH, that ending is an organic acid, right? We've got the OH ending, which is the alcohol. We have an O in the middle, that's an ether. Yeah, no, there are patterns, yeah, for sure. Okay, so I'm going to show you another thing you could do wrong, and this one's just kind of random. Okay, this is like my brain had a glitch. Uh-oh. So this would be wrong. Yeah, where'd that plus sign come from? They just got excited and put a plus sign in there. Yes? So I imagine what happens is that, you know, because this happens all the freaking time. Yes? I imagine what happens is people are writing a quiz or a test and they're maybe a little bit nervous and their brain goes like, and they write a plus sign, right? And then I write, no, you're supposed to multiply, not add, and they get it back and they're like, but I knew that, oh my God, right? So I'm going to stress this again and again, so hopefully your brain doesn't do that. Yes? If you want to, you can. Doesn't matter. Yeah. It's multiplication, not addition. And literally it happens every year. So many people, those little pluses just jump down on their paper. Okay, you guys are going to take 7 minutes. 7 minutes, and you're going to do these exercises. Answers are in the answer key. Yes, the one you picked up last day. Okay. Oh, and one of them has a mistake in it. Number 4 has a mistake. There should be a squared term. It should be EI 3 plus squared. I'll just leave that there so when you get to number 4, you can know that that's a boo-boo. Okay. So one thing I want you to notice is that for this one, there were no reactants for number 5. And so it is perfectly acceptable to write it over 1, but you don't have to, okay? You can just leave it without the 1. It's only if you have no products that you need to put something on the top, so you put a 1 on the top. Either way is good. You write the liquids if there's more than one liquid in the system. But if you notice, okay, just a few things I'd like to point out to people. Number 1, you can put a 1 if you have nothing to put in the reactants, but you don't have to. You will never see me do that because to me that is a waste of my pen writing. Yes, I write too much as it is anyway. Just making sure we're feeling good about the liquids. In this equation, there is only one liquid in number 6. There is only one liquid in that whole equation. Do we include it? No. Do not include it if there's only one liquid. However, if we have 1, 2 or more, it could be, this has 3. I have a better pencil sharpener. Here, just take it with you, because that thing just eats pencils. And I used to have an electric one, but it broke. So, okay, so we have liquids, 3 liquids, so we would include them. So yes, yes, yes. And we never write the solids. But I will let you know, this is probably the only place you're ever going to see an equation that has that many liquids. Probably until you get to second year university when you start doing organic chemistry, because you do have organic things that mix with one another. Okay? So yes, we would include everything. We would include the gas and all three liquids. Okay? If there are two or more liquids, include them. If there's a single liquid, if there's only one liquid, do not include. Two or more liquids, there's an off chance. You know, it's one of those ones where maybe there might be 1 mark, but maybe not. Or you can just be like, I'm never going to include liquids, and I'll take that 1 mark hit and I won't worry about it. You know. Okay, so 2.3b. There we are. So we're going to take these equilibrium expressions, and now we're going to put numbers in them. Super easy. Just like grade 9 math, okay? Simple algebra. So we have an equation, and we are told that our equilibrium concentrations are these ones here. Now, one thing that you should know about the KEQ expression is all the concentrations in that expression are equilibrium concentrations. They are not concentrations that are while it's shifting or initially when you put reactants in a flask but no products. Yeah? So in the KEQ, all the concentrations are equilibrium concentrations. And isn't that nice? They've given us all the equilibrium concentrations. So watch how easy this is to solve. You'll be like, oh, I like this. So my KEQ, you do have to write your KEQ expression. KEQ equals, and don't forget what kind of brackets are we using? Square brackets. So my products, everything's a gas here, so I'm going to include everything. We have Cl2 times HF squared over HCl squared times F2. If you don't write that, you lose a mark. Yeah? So if you go straight to the next step, there's a mark gone. So that's like free. That's for free. But it's also a free, like, lose a mark if you don't do it. Okay? So this part right here is worth 1 mark. And this is going to be with you for the next 4 units, so you might as well get used to it. Okay? And now we're just going to plug in our values. Now this one, I'm going to shake you up a little bit because we are not going to use square brackets here. We're going to use round brackets. And after we finish plugging them in, I'm going to write down Y over on the side, but for now we're just going to write them in. So we have Cl2, which is here, 2.0. You would think so, but it gets even better. Not only are we doing simple math, but this is the one place in chemistry where you don't need to write the units. Because what happens is once you've done the calculation for KEQ, the units are actually meaningless. So there's no real point in having them. It will end up, the units would end up being different for every K value, because you would have, like in this one, you would actually end up with molar cubed over molar cubed, which will all cancel out and you'd end up with nothing, right? In other instances, you'd have like molar to the -3, like it's just all over the place. So KEQ does not have a unit. And so you do not need to include the units in the calculation either. So that is acceptable to leave out the units for KEQ and its calculations. So don't put them in there. Okay? HF, 0.60. And I need to remember to square that. And next we're going to have our HCl, which is right there, 0.50. And our F2, which is 0.40. And I forgot to square my HCl, so I'd better square that. Please take your calculator that you will be using on quizzes and tests and plug those values in and see if you get the same number as I do. If you get something different, I want you to wave me over and I'll help you figure out what's wrong with your calculator. Also, I'd like you to make sure that every day from now on, if you have not been bringing a calculator to class, what should you start doing? Bringing a calculator to class, because there's going to be a lot of math between now and the end of the year, okay? We're sort of moving out of the theoretical blah blah, at least momentarily, and going into the mathematical blah blah, okay? Now, why did I say we need to put round brackets around the numbers? Well, if I was to say, and I'm going to just do this off the side of the page, so, because I don't really leave room for it. If I say 0.60, what that means is, what is the concentration of 0.6s? 0.60. Yes? How many 0.60s are dissolved in 1 liter? Well, no, here there's 3. There's 3.60s dissolved in 1 liter. It's like saying, what's the concentration of this number? Yes? What's the concentration of the number? Does that make any sense? No. All right, if this looks ridiculous to you, that's good. If it doesn't look ridiculous to you, that's okay. You can just remember that the numbers have to go in round brackets, okay? Okay, so this would be like 3 moles of 0.60 per liter. I don't know. Anyway, it just doesn't make any sense, so it just leave it alone. So the numbers must go in round brackets, and the chemical symbols must go in square brackets because we are looking at concentrations there. So here we have, and we're going to put stars. I know there are already stars, but we're going to put big stars, okay, here and here. And we are going to do that because this you'll want to refer back to so you don't lose marks. And we've already said a bunch of these. You must write KEQ equals. You must write this bit here. If you don't do those, you are losing a half a mark each. Yes? You must use square brackets around the chemical formulas. So, yes, square brackets around NH3. No, round brackets around NH3. You must use round brackets around the numbers. So yes, to 0.30 in brackets. No, in round brackets, no to 0.30 in square brackets. And lastly, but not leastly, this is the one we mentioned before. The terms in the numerator and the denominator are multiplied. They are not added. So you don't want those plus signs dropping down on your paper out of nowhere because your brain had a glitch. So try not to do that. Okay? And now we're going to do some examples, some more examples. 2 more examples, and then we'll be done. We're looking at finishing this unit up next week, and we'll have a quiz on KEQ math, and then we will have our test. Okay, so we're looking at our test at the very latest would be like Monday, November the 7th-ish, something like that. Okay, I think that would be the latest. Okay, at a certain temperature, we are given the concentration of H2 and I2, so we know the concentrations of H2 and I2. And we are also told our KEQ. So this is a little bit different. We're not just solving for KEQ, we're solving for one of the variables. But if you can do grade 9 algebra, you can do this question. So, first thing we're going to do is we're going to write our KEQ expression. KEQ equals my products. I've got concentration of H2 times concentration of I2 over concentration of 2HI? Just HI. Yeah, HI squared. Concentration of HI squared. Now, what is my unknown here? What am I looking for? HI, so I'm looking for that. So we are going to solve for HI. Okay, so I'm going to do that, and you're going to let me know if the algebra is problematic, and I'll do the algebra for you, okay? And in fact, we're not going to solve for HI, we're going to solve for HI squared, because that means it don't have to keep writing a square root sign until the very end. So we're going to solve for HI squared. HI squared equals H2 times I2 over KEQ. Would you guys be able to do that algebra on your own? Or do you want me to go through it? Go through it? Okay. So what I've got, and I'm going to do it over on the side because I don't have a lot of room here. So we have KEQ is equal to H2 times I2 over HI squared. And so if you want HI all by itself, you need to get it up into the numerator. There are two ways of doing that. You can multiply both sides by, I think this is how the math department does it. Is this how the math department does it? Yeah, okay. HI squared, that cancels out, yes. And then we want to get rid of the KEQ because we want HI all by itself. What are we going to do next? Divide both sides by KEQ. Okay, and that gives us HI squared is equal to H2 times I2 over KEQ. I don't do math like that because it looks messy to me. I'm like, ugh. But if that works for you, like totally do it. I don't mind if it looks messy to me. If it's your work and it makes sense to you, that's all right. What I would do with something like this, I would have KEQ. I just kind of do it in my head, which many of you might be able to also do, right? What's happening in my head is that I know that this needs to move up over here. I don't actually write that arrow. And then this one needs to move down. And so I'm just kind of swapping them in my head. If you can do that, that's great. If not, do it however the algebra works for you. I will be able to figure it out as long as it is correct. Okay? Yeah. So once we have that, now we can just start plugging in numbers. So we have, let's see, my H2, I have 2.5 times 10 to the minus 2, and I don't need to write molar, but I do need to put it in what kind of brackets? Round brackets. And my I2 is 3.1 times 10 to the negative 2, also in round brackets, over my KEQ, which is 8.6 times 10 to the negative 2. And we get oh yeah, no, we're squared, we're good. Yeah? Yeah, we're still squared. We're not done yet. We're still at HI squared, yes? Yeah, we're good? Okay, no, we're good, okay. So 2.5, make sure you plug this into your calculator, see what you get. Make sure you get the same number as me. Make sure I'm getting the right number. And I get 9.01 times 10 to the negative 3. Eventually, how many sig figs will I want? Eventually, I'll want 2, so while I'm recording my work, if I press clear on my calculator, I've got an extra digit there that will help prevent rounding errors. Yes? So I usually record one extra digit until I get to the end of the question, and then I round off. But I'm normally working with the number in my calculator. That extra digit is just in case I press clear and I need to punch it in from scratch. Now, are we done? No, because we need to take the square root of that. So concentration of HI is equal to the square root of 9.01 times 10 to the negative 3. And we get 0.0949. Are we done? No. What do we need to do before we're done? Sig figs. So how many sig figs? 2, because we got 2 and 2 and 2. So it's going to be 2 significant figures. So that's going to then become 0.095. And now, even though we were working, is there anything else missing here? Anyone see what else might be missing? Yeah? Yeah, we do need units because this isn't a KEQ, this is a concentration. So yes, we do need the units. Okay, and if you are very kind to your teacher, what would you do at this point? Put a box around it. Yeah? Because that makes it really easy for me to see what you want me to focus in on as your final answer. Okay? Now, would it be okay to write this as 9.5 times 10 to the negative 2 molar? Is that good? Yeah. Either one is fine. I want to show you what I did with my other block because it kind of goes to the point of what I sometimes see on people's tests that makes it really hard to follow their work. Because what I did made it really hard to follow my work. Where did it go? There we are. Okay, so you see how I have step 1 here? I wrote my KEQ expression and then I solved for HI, and for some reason I did it way over here. Yes? So I did that and then I ran out of space. When I solved for HI squared, I ran out of space. So what did I have to do? I had to do my third step way over here. Now, do people normally, in the English language, do we read from right to left? No, we do not. So it would be very kind if you did something like this, if you numbered your steps 1, 2, 3, or if you provide arrows going from one place to another. Yes, you're like, okay, we go here, and then we're going over here. Do you know what I mean? And then you box your final answer because it's like, okay, here is my answer. So especially if you do something like I did and you kind of didn't plan your space well, that's okay. Also, never be shy about asking for extra paper if you're not good at writing in the space I provided. Some people have bigger handwriting and it's like they're trying to cram it in there and it's not working. Just ask for extra paper, okay? Yeah, so we're going to go on and do the next one. One last example. Example number 3. Here we have a complicated reaction with lots of big coefficients. And it takes place in a 5-liter flask. What is different about this question from the ones that we are previously done? We got liters and also, yeah, we've got grams instead of moles. The KEQ expression must use moles per liter. So what are you going to have to do with your grams? You're going to have to take your grams and convert to moles. Then you're going to have to take your moles and divide by liters before you can use your KEQ expression. So there's a lot of work here. Yes? So if we're going to find, oh, look, I can get away with, if I go check up here and I go, do I need to include everything in my KEQ expression? Get that liquid out of here. That means I don't need to calculate anything with water. Save myself some work there. Yeah, that's nice. That's really nice. So now what we need to do is we need to find moles of NH3, and we're starting with 17 grams of NH3. How do I find moles? Yeah, I'm going to have my 1 mole per whatever the molar mass is, which happens to be 17 grams. Isn't that nice? Because that means our math is super easy and we get 1. Now, how many sig figs? 1.00 moles. I'm going to keep those there because I don't want to forget that I have 3 sig figs. Yes? Now, I'm going to find my, what I do not want to do is I don't want to do this. Why not? Is this equal to that? This is equal to 1, this is equal to 1/5. 1 does not equal 1/5, yes? You cannot do that. And if you want to see in my lab book when I did that, and it's like you cannot write equals between things that aren't equal, right? So I'm hoping to save you grief later in your life. Okay, you cannot write an equal sign between things that are not equal. So what you're going to do at this point is you're now going to write concentration of NH3 equals, and I'm just going to put like a dividing line there so I know that I'm starting something new. Concentration equals 1.00 moles over 5.00 liters, and that's 0.200 molar. We're going to repeat that process for our oxygen. Yeah, it's pretty much the same thing. It's 32. Yeah, it's going to be 0.200. I like to be thorough, so I'm going to write the whole dang thing, but that's me. And our last one, sadly, it's not going to be 1 mole. So we have moles of NO, 26.0 grams of NO times 1 mole per, in this case, it's 30.0 grams. And that is, why is it 30? Because 14 plus 16, yeah, gives us 30. And so we get 26 divided by 30 equals 0.86 repeater. And I'm just going to leave the repeater there because I'm not done yet. I would never leave that in a final answer, but here I'm just like, whatever, just leave it there. And our concentration of NO then is 0.86 repeater moles over 5.00 liters. Oh, 0.173 repeater molar. And again, I'm not done my calculation, so I'm not going to worry about the fact that I've got a repeating thing there. Now what? Now we write our KEQ expression. KEQ equals, where are we at? Oh my gosh, concentration of NO to the power of 4. I'm going to get you guys to try this on your calculator because I want to make sure you know how to like do powers of 4 and stuff. Over NH3 to the 4. And what's our last one? O2 to the 5th. Round brackets now for our numbers. Let me know if you get something different than 1,763. Did you get something different? Try plugging it in again. Let me know if you still get something different. This then, of course, would round to how many sig figs? 3 sig figs, 1760 or 1.76 times 10 to the 3.